Hello. So, not sure how many people made it to the panel this morning. It looked like a lot of attendance, right? And one of the discussions that had come up in the panel this morning was how many workflow managers do we need? Well, yet another one. That's my discussion today. So I wanted to bring that up. I thought that was a really useful discussion. So Canary is a new workflow manager that's coming out of Sandia National Labs, and one of the things that we started hitting on were some of the duplication efforts across a lot of the labs, a lot of the computing programs that we had at the labs, and we have scheduling and reports, and those are really highly complicated results to get right every single time. And we're duplicating them across multiple different frameworks, multiple different testing frameworks, multiple workflow frameworks. All of this to say that if we're going to do the same thing over and over again, maybe we should put it in one place. And that goes the same for, preparing workspaces. Every test framework's going to have to prepare a workspace, identify its own resource sets, gather the results, and tear down the workspace. It's general things that basically every test harness is going to have to do. So then we get down to the one thing that typically is harness specific and why we can't go from harness to harness to harness. And that's generally your test files, right? Like you write your test file to be geared towards one language, and then you say, oh, cool, now I have 1,500 test files, and if I ever want to change, now I have to rewrite every single one of those. Oh, yum. So one of the core tenets when writing Canary was that we wanted to be able to make a test framework and test runner diversified across a large hardware environment space. That includes your tests. We wanted a single test runner across many applications and systems, and that was the design from the start. We have intended to be able to reuse all of the testing frameworks, all of your one-off use cases, all of your legacy problems that you need to move forward because you haven't yet gotten rid of the tech debt that you've been trying to beat with a hammer for 17 years. Is that just me? Okay. So some definitions to get into here. We have test cases. This is what Canary defines as a single test instance and what the values are for your test to come back and say, oh yeah, I was correct, right? General test case, and this is the interface that Canary uses when defining what a test will run and execute as. So we have those, and then we have test suite, which is a collection of those test cases, a test framework, which is how you get into the guidelines for the rules of execution, how your tests are actually going to be executed on its nodes. Fixtures are your environment setups. So I need 16 globals or 17 globals. We forget the numbers sometimes. And then we have our test runners, which is what actually goes and runs. That's going to be what launches your process and says, hello, I have results for you. So if we take this a step further, we step back out a little bit, we see that we have a few nodes at the start. Every test harness is going to do its startup. Canary allows you to override even from that moment. Everything on the right-hand side that you're seeing here are your implementation methods that you can overwrite from a higher level. So if you write your own plugin, you can say, hello, I don't like Canary's startup. Let's write something else instead. All the way through the initialization, where you're creating your test session and describing what your directories are going to look like, how you're going to implement your search, and what your test files look like, down to the filtering and masking. Everything is completely overwritable here. Now, one of the things that a lot of the test frameworks internal to Sandia have, and this is one of the core tenets of our reason for doing this, is we have batching and scheduling across HPC nodes, and we want 100 test jobs to run on one node and 100 test jobs on the next node. And sometimes we want 80 on this one because we got a bigger test, and taking into those kind of resource allocations and some stuff there, right? We have a batching use case for Canary, and we get into the test cases that are being batched here. We have, if you're going down the batching route, Canary will split up your files and say, well, 100 tests for this one is probably about right. We're still doing some guesstimates here, but it does batch them up for you. and submits them to a plugin we're going to talk about a little bit later called HPC Connect, which is another core piece of Canary, which handles the HPC abstractions. If you're not going to do that, you can just run locally. It'll do the normal test run environment setup and just localize all of your runners across how many ever cores you have. So let's talk about some of the HPC challenges here. So we have resource management. We have legacy testing requirements and launcher abstractions. How many people would like to write another way to execute on Slurm? Yeah, that's yeah. Done it enough, I suppose. Fair. Okay, so Canary's kind of chasing after a few goals here. We want the resource manager to be able to handle all of the HPCs that we're commonly executing on, but that doesn't mean it's just HPCs. We want to be able to distribute across all of your nodes internally if you'd like. As long as you're willing to give us the computer's name, we can run there and manage the resources on it. Canary provides extensible test specification, which is really important if you're coming from the legacy test background and you have 15,000, 20,000, 25,000 tests, and you don't really want to particularly go rewrite all of them. You need to adapt them into the new framework, right? So the last one is going to be your submission abstraction, and we have a bonus in here that I'll get to at the end that's just kind of a fun usability thing that we've hit on with some of our users. Starting with resource management. So Canary defines what we call a resource pool file. It's basically just a JSON file and describes all of the resources that you could possibly need as part of your test runs and executions. So we have our resource pool file, and this one is an example using CPUs, and we have 4 of them on the bottom and 2 on the top, and you have however CPUs you need for your test execution. It's going to find those at the start of your call, whether or not you specified or not, and write it to the file. So it'll do auto detection there, right? On the other point of that, we have GPUs, because we manage those as well. The important part here is that right now we're only looking at NVIDIA GPUs automatically. You can describe however many other GPUs or other resources you'd like for Canary to manage, and it will just happily manage it. But right now we're only auto-detecting for CUDA and NVIDIA. So the way you get around some of this, where it's, doesn't find however many resources you do need, is that you can override all of these options independently. In the resource files, you can do this with canary-c resource pool and then a name and an object count. Now the fun part about this is, let's say you need however many FPGA boards as part of your test files. You can do that. It'll keep track of them, and it'll count them as consumable objects so that you can have any number of them needed per test. Moving on to some of the legacy testing requirements, and the way we think about this is that Canary offers flexibility to be used in a large legacy testing environment with plugins and configurations. Out of the box, we handle VVT files, PYT files, and CTest files natively inside of Canary. That way, if you happen to use one of those, cool. If not, we can allow custom test files through a plugin interface, and that includes all the way through your executions and how those test files are ran. This is something we'll get into a little bit more as we go through the legacy use case that spawned our conversion to Canary. But we have complete control from onset of test file all the way through the test case execution. And next we have the Canary HPC abstraction. Again, how many times do we need to write a Slurm plugin, right? So Canary's actually taken this a step further and said, well, we don't really want Canary to know what your HPCs look like. We don't really want Canary to know. Does your test framework need to know what it's executing on? And we were like, well, not really. It just needs to run somewhere. So what we did was actually split out the HPC management into its own plugin. And if you'd like to go play with that, it's a separate actual tool that you can get off of PyPy right now. It's in a separate Git repository. It's its own plugin, and it handles Flux, Slurm, LSF, and standard shell execution out of the box. We have some bonuses on this at the end of the presentation. This is getting some extensions coming in the future that are kind of fun to talk about. And finally, this is a user-requested thing that was recently finished for the Canary side that we thought was really interesting. And I thought it kind of pertained a little bit to this conference, particularly with the idea of SPAC being rather popular here. So a lot of our users came back and said, well, I don't really want to have to pass all these environment variables and stuff, extra command line variables. I want to pass what it is that a test execution is. Now, I can take my SPAC environment and go over there and run it. So why can't I do that with my testing environment? So we implemented a management tool called Canary Workspaces that allows you to do exactly that. You give it an initialization, you find your tests, you filter them, you store them on disk, and you can go run them on 18 different systems if you'd so like, with whatever compiler, backend, test frameworks. It doesn't matter to Canary. It's got your list of tests. And the only requirement right now is that it has to be a shared file system, because we're not in the business of transporting your files all the way back and forth across the HPC's environments and networks yet. Maybe one day. So let's go through a legacy example real quick, and this is particularly why I'm up here today and why I'm a part of the Canary team. I worked a lot with Sierra's test framework, and Sierra is a multi-application physics code inside of Sandia National Labs, and I've worked over a decade on maintaining the test framework for Sierra. And Test Run is a large-scale test framework which supports multiple high-end computing platforms across laboratories. So we support LANL, we support Lawrence Livermore. We run on all of them, and this test framework runs anywhere we can get our hands on extra compute powers. So Sierra's maintained that, and it has led to some really large-scale maintenance burdens. We have managed to get ourselves into a distributed testing pool case where we thread lock occasionally and leave processes everywhere. It's lovely. And in general, it makes the debugging hard when all of your tests are written in XML. It happens to just be a large bash script. Sierra has paid the cost for Test Run for a very long time. This has been going on. Even before this, it was called Run Tests, and it just goes on forever. It's like 20 years. And at the start, it probably had some semblance of what architecture looks like. I don't know where that went. I don't think anyone does at this point on the team that maintains it. Test Run has lost that. Growing pains have left supporting new platforms to be kind of painful. And in general, we wanted to maintain a more widespread use of a testing framework across the advanced simulation and computing community. So this was a movement by Sierra and some of the other application codes to come together and say, well, we all kind of run on HPCs this way. Let's make one tool that does it, and provide an opportunity to kind of get rid of each one of us rolling our own code. So Canary comes with plugins. It's designed to have basically the same concept as PyTest. If you've ever seen PyTest's plugin framework, it's called Pluggy. We use that in Canary. And we wanted to do that particularly because it's a well-documented interface for defining plugins. We didn't really want to roll our own plugin management and then just be like, oh yeah, but if you design this, and then you can't use it anywhere else either. So that's where we went there. And this allows us to override basically every method that we need to go from your test case parsing to the execution nodes on the platform being specialized if we wanted to. So In this case, we're just showing a simplified version of what it is that Canary defines inside of the init py. So this is the Canary Sierra plugin in a roundabout way. We're not going to show off 300 lines of code and expect you all to read it. It's not going to be very fun. But the core tenet here is that we define a generator, what a generator is for Canary, and then we define what it looks like when our test case finish. So we have our results properly stored in Canary's output files. And each one of these are done through hook implementations that are going to call back to the plugins. Now, how much does this really cost? Right now, so looking at Canary Sierra right now, this is the entirety of the code base and the side of the plugin to transfer 25,000 tests. There are 5 files. Roughly 1,721 lines of code, and that is probably about half the number of lines of code in our original test framework. Most of that actually came from the original test framework as part of the parser. So if we look through parser.py, rules.py, and utils.py, all of those are really just transitions from the previous test framework. What we had to write, the requirements for writing, for Canary to work with our test framework roughly translate to about 400 lines of code. That was the entire infrastructure management for the glue code to Canary. And that was including special one-off cases that we do odd things in, and the inclusion of us having a template bash script that we write out after every test. So parser.py is by far the largest bulk of the code. It was taken from test run, lightly modified to refactored so that it would provide the same interface back that Canary would expect. And it still has to deal with all of the complicated XML and bash use cases. But really what this is showing is that you can bring your own standard in Canary. You can bring whatever test file, if you can write it, you can bring it to Canary. It'll parse it happily, and as long as you give it in the data format back that it wants, you're good. So generator.py is the other side of it, and it's responsible for filling in those variables. This generator.py is really the glue code. If you write your test, you needed to generate some form of test case for Canary, and this is what's doing it for Canary Sierra. It also includes, and this is built into Canary, so as long as you hook it up in a nice manner, you can have filtering of all of your tests. So if you have a keyword that says, only run my unit tests, Canary will happily go through and do that for you as well. So what is actually required for you to spin up your own plugin for Canary? The minimum things that you're going to see that are required for that spin up are matches, describes, and lock. You have 3 things that are actively required. You have to tell it what kind of file it is looking for. So if that ends in a .t, it has T, or .ini, if you're writing initialization files, if you got TOML files and those are your tests, that's fine, but you need to tell Canary to pick those up, right? Then the describe function. Your describe function is going to tell it, well, this is what it looks like when I print out the test file, because it's going to be able to give that back to the users through its own systems, right? So if you've ever written a repr function in Python, think of it about the same as that. It'll print out it'll print out really the test file that you've given it, however the user would like to see it. Now, the last one's lock, and that one's a bit more complicated. That's the function that's most important to execution environment of your tests. That says, I have X tests, these ones made it past my filters, and now they're the ones that I'm going to execute. So generate a single test case for all of them. So it's a bit more complicated. This is where you get into the entire list of your tests is finalized and completed. That's basically all you have to do for your core Canary needs, though. You have 3 functions to define, And for that, you get a lot of value as far as Canary goes. It has its own status updates. It has its own resource management built in. It can batch. And all of that, the keywords filtering, for 3 functions. So how hard was it for Canary to be used in Sierra? We have a little bit more work to do to complete the transition of all of our platforms across, and we have a lot of ongoing work in other areas that some of the other members of my team are actually here to talk about as well. And the general test execution, in about 3 to 4 months, we managed to get about 20 out of 2,200 or 22,000 tests to transfer over. So those were completely executed, and we had some one-off cases that we just hadn't completely implemented. Sierra's transition, which has been extensive and a complex test suite, does represent a very nice case study in what it's like to transition way too many files over to a different test framework, though. So I thought that was very fun. Not having to rewrite 25,000 test files was ideal in that case. And one of the really valuable parts of this experience has been going around and working with the other codes teams that are near Sierra, but we don't always have the best communication with. So we've been more collaborative in bringing this up, and a lot of that means we've had shifting interfaces across different code teams that we've had to deal with back and forth. So we've had lovely API breakages because one team needs one thing and another team needs another thing. So once we stabilized, it was actually really interesting to see how it worked across all of the code teams at once, rather than each code team rolling their own test harness for the first time in a long time. That gave us alignment, which was huge for the internals, but we'd like it to go further. A lot of people are doing, HPC testing, HPC development, HPC workflows across HPCs everywhere. So we want to share this with the community. We want people to look at it and take a second and see, hey, maybe it's useful for me as well. We'd like stronger sustainability, and we'd like community involvement in applying what we should be sustaining, whether that just be HPC Connect or that's Canary Core. We would like input in a lot of those areas. And some ending notes. Please go check out Canary and HPC Connect on GitHub today. The plugin for high-performance computing is separate. And one really fun plugin that I think Tim is still working on a few of the bugs in is the Canary dist, which will allow you to give Canary a file containing all of your resources, and it'll find the actual resource map for what it needs out of all of them. So you can say, I have 16 random workstations, and I want to use all of those for my testing. So there's a little bit there. We have a lot of other plugins that are worth looking into. And I'd just like to say thank you to Timothy Fuller and Matthew Mosby, as they've put in a lot of work across this throughout the years. And Tim designed a lot of this on his own. So it's been really cool to see all of this kind of come across all of our teams. If you have any questions, feel free. And thank you guys for coming.
Thank you for that talk. I was wondering if you could talk a little bit more about the deployment scenario, because a lot of the commands you show of like Canary running were through like a command line interface, which sort of makes me think of something like a cron job or a systemd timer, or some sort of, you'd have to set up a hook between committing your code to having it run with Canary. And so so this would be, so is this sort of targeted like at a developer having like the developer accounts on their HPC and sort of like running? I'm trying to understand how it can distribute, and like can the same command distribute to multiple systems? So
yeah, it's primarily designed for developers and analysts, really. If you want to go and run this across an HPC, you can do that. And that doesn't have to be your test. It's any file. It's really an execution tool for, I want to go and execute, but I don't really want to know the internals of Slurm. I don't want, specifics in my environment to be known at that time. I want a configuration file for that. However you'd like to execute your code. In general, it comes purpose-built for being a test harness, so primarily for the developer use case, right?
Right. Okay. And so then, do you have some way of reporting that back into some like web
Yes.
tool where you had those? Okay.
Yeah, so we can actually have Canary get back and actually report to GitLab, make an issue for you. We have it so that Canary comes out of the box ready to report to CDash if you support one of those instances as well. And in general, if you can get the data back, you're fine. It just depends on the HPC that day.
Okay. Thank you.
Yes. Any other questions? All right.
We often have like a simulation code that runs some output and then has a checker afterwards to verify the output. Yes. Are you able to ensure the checker runs on the same node? Because then we have
believe that yes.
You believe?
I believe that yes. I don't remember the exact logic for the setup. Can you change it? Yes. I guarantee that one. Because you can overwrite the entirety of that, so you can wrap your code in whatever kind of test you'd like, which includes the teardown, the setup, and all of the other functions.
Okay. So if you go back to the slide where you set up the environment, I have a question.
That's the wrong button. This one? Which slide exactly are you looking for?
Where basically you say that you need a distributed shared location for setting up your Canary.
Generator?
Yeah, that slide. That's
That one?
the
Okay.
one.
This one right here?
Yeah, workspace, right?
Okay, yeah.
So one question I had is basically compiler versions and things like that keep changing every time, or almost, right? So if you create a workspace, how does Canary update itself, or does it update itself if the compiler version changes, or how does it?
So Canary's not tied to your compiler version. It doesn't actually care what Intel compiler, GCC compiler, Clang compiler you've chosen that day. Canary really just cares that it has what it needs to execute a test.
Okay.
So if your test comes back and says, well, I need the Intel compiler, well, that's a different story, right? Now it's going to say, well, I can't execute that test because the resource that I have required is Intel, and I have 0 of it.
Okay.
That's the way, in general, that's going to end up working. Now, that being said, a lot of that's done through the path and the environment, and there's an update method that you can call separately to make sure that your tests are still where they are, in the case you decided, oh, I deleted that directory, but I forgot to change my selection, right? It's also held in a database, so you can actually update, manage, and modify all of that from the command line so that you can go to town choosing the very, very specific test through 16 filters if you wanted to.
Okay. Okay. Thank you.
Of course. Any last questions before we're done here? All right. Well, thank you all for coming out.